Hello and welcome. In this lesson, we will talk about the average and instantaneous rates of change. This lesson has been prepared for students who are taking the Calculus and Vectors course, MCV4U. We're working on the first unit, limits, and this is lesson 5. So let's get started with the average rate of change. To determine the average rate of change of a function means to find the rate of change of the y values over a specific interval within its domain. Now, the rate of change of the y values of a function can be difficult to find due to the curved shape of the graph of a function. So to help us determine the average rate of change of it over a specific interval, we pick 2 points and then we draw a line that connects these 2 points. Now, the line that connects these 2 points is called a secant line. So by definition, we say that a secant line connects any 2 points on the graph of a function. Now, the slope of the secant line will measure the rate of change of the y values on the secant line. And that will help us determine the average rate of change of the y values of the function. Now, to find the average rate of change between 2 points on the graph of a function, like indicated, for example, on this graph, point P with coordinates x, f of x, and point Q with coordinates a, f of a, we use the formula for the slope of any straight line, delta y over delta x. So delta y over delta x, or in other words, f of x minus f of a divided by x minus a. So let's take a look at an example where we can find the slope of the secant. We are given the function f of x equals x squared plus 2x plus 1. We need to find the slope of the secant that passes through the points P, where x equals 2, and point Q, where x equals 3. Now, in order to find the slope of the secant, we have to know what the coordinates of each point are. And we are given just the x coordinate. So the y coordinates will be found by substituting the x value into the function. So we're going to say that point P will have coordinates 2, f of 2, and point Q, 3, and f of 3. By direct substitution of 2 into the equation of the function, we will get that f of 2 equals 2 squared plus 2 times 2 plus 1. So that would be 4 plus 4 plus 1, 9. Similar to this, we have f of 3 equal to 3 squared plus 2 times 3 plus 1, which is 9 plus 6 plus 1, or 16. So we're going to say that the slope of the secant equals the change in the y values, so I'm going to call them y at q minus y at p, over x at q minus x at p. Now y at q is 16, p is 9, divided by 3 minus 2. So that will give us the slope of 16 minus 9, 7, over 1. So the slope is 7. Now the equation of the secant that is passing through these 2 points means that we're trying to find the equation in the form y equals mx plus b for a secant line whose slope equals 7 and passes through the points 2, 9 and 3 and 16. We can use either point to find what the equation is, and I always tend to choose the point with lower coordinates. So in this case, we're going to say this is the x and the y that would help us find the equation. So you substitute y here by 9 and x by 2 to find the value of b. So 9 equals 7 times 2 plus b. So 9 minus 14 equals b, which makes the value of b equal to -5. So therefore, we're going to say that the equation of the secant line is y equals 7x minus 5.